Can if you explain no? What all we have discussed in mass spectrometry? Deepen. After long that you are attending class, I think so. Monisha, Subhadarshini.
Yes, ma'am.
Say what we have
Mass,
discussed in class. Yeah, Monisha, proceed.
mass spectroscopy is used to study the molecular weight. Uh, in 1886, Goldstein find out that movement of ions in magnetic and electric field. In 1899, Wilhelm identified the mass to charge ratio. In 1918, Arthur Jeffrey find out the LCMS and gas chromatography mass spectroscopy. Principles or ionization, fragmentation, acceleration, and detection. In ionization, we can solid liquid gas. For the method of ionization for gas or vapor sample, electron impact ionization, chemical ionization. For solid or liquid sample, electron spray ionization, matrix assisted laser desorption ionization. In electron impact ionization, it gives enough energy for the fragmentation. Um, Impact means electrons bombard striking electron to the sample by electrical heating it emits. The energy required is 10 to 15 electron voltage. It's called the parent ion or molecular ion. Fragmentation process, it 70 electron voltage energy for breaking of bonds into small pieces.
Okay. Good,
So,
Monisha. Very good. So we have discussed about the introduction theory and history and the principle behind mass spectrometry. In principle, there are four parts: ionization, fragmentation, acceleration, and deduction. In ionization, we have discussed the methods like electron impact ionization, chemical ionization, electron spray ionization, and MALDI, matrix assisted laser desorption ionization. In that electron impact ionization we were discussing, in that it requires through electron impact ionization we'll be applying high energy electrons to the molecule in order to get parent ion or molecular ion. So, okay, after getting molecular ion, it will be going for fragmentation with a high energy electron voltage, that is 70 electron voltage energy is applied to the parent ion for making it into different fragments. Now let's discuss about what are all the process the molecule will go for fragmentation. Okay, what are the pathways or what are the patterns, fragmentation patterns or rules followed for a molecule for going for fragmentation at this energy level, that is 70 electron voltage energy level. The molecular ion which is formed through ionization process with 10 to 15 electron voltage, how the bond breakage occurs in order to get the fragments. I told fragmentation is nothing but breaking of bonds to give small pieces. Now let's see what are the patterns. The first one is simple cleavage method. Second one is a hydrogen transfer rearrangement. Third one is retro-Diels Alder reaction. Fourth one is McLafferty rearrangement. Okay, and this is an important question under mass spectrometry regarding fragmentation patterns. Okay, and fragmentation rules are there, that is separately we'll discuss. These four processes are said as fragmentation patterns. In that we'll see what is simple cleavage method. It is otherwise known as it is divided into two types, homolytic cleavage and heterolytic cleavage. Homolytic means bond breakage occurs. You can find here. Homolytic means bond breakage occurs between similar type of atoms like carbon and carbon, between carbon and carbon. When heterolytic cleavage occurs between two different atoms like carbon hydrogen carbon hydrogen or some carbon oxygen if it is attached with oxygen, or some heteroatoms if it is attached, then bond breakage occurs over there for forming fragments, then it is called as heterolytic cleavage. Okay, homolytic means between similar atoms the bond breakage occurs, where in heterolytic cleavage different atoms, hetero means here different atoms. Okay, either carbon oxygen or carbon sulfur or carbon nitrogen, whatever heteroatoms or halides attached to carbon, that bond breakage occurs in heterolytic cleavage. Okay, so this is about simple cleavage method. So once the fragmentation formed through either homolytic or heterolytic, one of the product from the main substrate or reactant, one of the product through this chemical reaction it will be forming through the simple cleavage method, the product will be carrying positively charged ion. Okay, and whichever fragment is carrying positive charge ion is called as a fragmented ion, and that ion will be detected in mass spectrometry. Okay, cation, fragmented cation will be analyzed or will show signal in mass spectrum. So that is analyzed by mass spectrum. So mass spectra will be giving information about molecular ion peak and fragmented ion peaks, so that we can find how much what are all the different groups are existing, what are all the isotopes are existing for a same molecule. Mainly for isotopic study, this mass spectrometry is widely applicable. Okay, how much intensity each fragment is present in the molecule, what is the molecular formula of fragment, what is the molecular weight of fragment, analyzing this fragment will give more information about the chemical structure of the molecule. Okay, that is why fragmentation pattern is very important under what mass spectrometry. In that, first method is simple cleavage method, homolytic or heterolytic cleavage, and the second one is hydrogen transfer rearrangement, where hydrogen atom will be transferred from a particular group for intermolecular hydrogen bonding, how it is transferred, or to ethylene groups, alkene groups, hydrogen atom will be transferred in hydrogen transfer rearrangement. Then in heterodiol solder reaction will take place in aromatic groups, compound which has aromatic groups will go for heterodiol solder reaction, and it will give ethylene fragment. Okay, ethylene means alkene fragment it will give. So that is the reaction followed behind heterodiol solder reaction. Then McLafferty rearrangement occurs at alpha and beta position. Okay, alpha and beta position of the carbonyl compound. If you take any carbonyl compound, it will be having alpha and beta carbon to it. Okay, so where bond breakage occurs between alpha and beta carbon, and from the gamma carbon, transfer of hydrogen group occurs to the functional group present at carbonyl carbon. Okay, so that is called a McLafferty rearrangement. This can be followed in carbonyl group containing compounds. So in all the process, you may find one of the product formed fragment through fragmentation will be carrying positive charge, so that ions can be detected by mass spectrometry. And the next ionization process is chemical ionization. So with this fragmentation pattern completes, what are the reactions it will undergo? First one is simple cleavage. Second one is hydrogen transfer rearrangement, Diels alder reaction, then McLafferty rearrangement. Okay, in homolytic and heterolytic cleavage, between the similar type of atoms or between the heteroatoms, different kind of atoms, the bond breakage occurs to form fragments. In hydrogen transfer rearrangement, hydrogen atom will be transferred in alkene groups and it will give fragments, thereby it gives fragments. And then in heterodiol solder reaction, aromatic groups conjugated dienes will be going for fragmentation, where it will give ethylene as fragment. And in McLafferty rearrangement, between alpha and beta carbon, bond breakage occurs, thereby fragment forms, and from the gamma carbon, one hydrogen will be transferred to functional group which is carrying carbonyl group. Okay, so that it becomes a hydroxyl group, and the ion formed will be called as McLafferty ion and McLafferty rearrangement. Okay, so in McLafferty rearrangement, the compound should contain alpha, beta, and gamma carbon, where between alpha and beta carbon bond breakage occurs. What is alpha and beta carbon means? Next to carbonyl group, C double bond O group will be there, no? So next to that, whatever carbon is attached is called as next to, immediate to functional group. Whatever carbon is attached, that is called alpha carbon, then beta carbon, then gamma carbon. So between number 2 and 3, carbon number 2 and 3 bond breakage occurs, and from the fourth carbon, that is gamma carbon, one hydrogen will be transferred to the functional group. That is the reaction occurs in McLafferty rearrangement in order to give McLafferty ion, and this ion also will be detected in mass spectrometry. Okay, and next about chemical ionization. Next ionization process is chemical ionization for gaseous molecule, and which is also commonly used ionization method, where we'll be using methane and ammonium gas or isobutane gas. Okay, neutral gases are generally preferred. When analytes are in gaseous state, what first it will go, this gases, neutral gases, will undergo first electron impact ionization, so that it will give molecular ion. Okay, and this molecular ions, when it is present, gaseous ions present, they will collide with your sample molecule, thereby the molecule becomes, through collision method, the molecule analyte of interest will become ionization, will go for ionization, thereby cations are formed to analyze by mass spectrometry. Okay, see here, in brief I have given about fragmentation pattern, that only what I could find the title here with explanation, it is there. We'll discuss once again about a fragmentation pattern. So now we'll see about chemical ionization, that is second part of ionization. In the first part, electron impact ionization, you know how much energy was used for ionization and fragmentation. So after then, when you go with chemical ionization for an analyte, first the gases will be, chemicals are nothing but here gases, neutral gases. For example, methane gas, ammonium gas, or isobutane gas. Either these are all examples. Okay, so when these gases are collide with, or they are impact, are bombarded with high energy electrons, like electron impact ionization, this gaseous molecules will become ions, like molecular ions they will form. So when these ions collide with the analyte molecule in the ionization chamber, just think that all gaseous ions have been formed through electron impact ionization. So this gaseous ions will make our analyte ion to become ionized, to become molecular ion. That means it transfers its ionization charge to our analyte through collision method. Okay, that is the concept behind chemical ionization. Thereby, the molecule will get ionized, and that will be detected by mass spectrometric detectors. And chemical ionization is not fit for fragmentation. Enough energy for fragmentation is obtained from electron impact method only. Okay. But chemical ionization is also used widely for ionization process in order to analyze molecular mass of the compound. Now let's here with examples you can find for fragmentation pattern, simple cleavage. Okay, if it has radical cation, see the fragmentation patterns. When the molecular ion, when fragmentation it undergoes molecular ion, once it is formed, that is M plus ion. M plus ion, when it will get positive charge, when it loses one electron, when the molecule loses one electron, it will be getting positively charged ion, where it will be having one free radical, that is radical, free electron will be there. In the neutral state, it will be of paired electrons. When when it loses one electron with a high energy voltage, it becomes positive charge and it will be carrying one radical. So this ion is called as the radical cation. Okay, when this radical cations or neutral cations, even number paired electrons will be lost for neutral cations. There are two kinds of cations you can find: radical cation and neutral cation. Where radical cation, when it undergoes simple cleavage through homolytic and heterolytic cleavage, okay, you consider when homolytic cleavage occurs means when the molecular ion carries only positive charge, or you can find the cleavage occurs at alpha position of the carbon, so it is otherwise called as alpha cleavage. When heterolytic cleavage occurs at radical site cleavage, okay, it is called as radical site cleavage. That means at radical cation, at the radical site it will be going for breakage in the bonds. Okay, and this is otherwise known as inductive cleavage also. Between different atoms breakage occurs when at radical site. Where you can find radicals at the atoms? On heteroatoms you can find free radicals located on it, means non-bonding electrons. So at that site heterolytic cleavage will occur, so it is called radical site cleavage. Where homolytic cleavage occurs at a positive charged cation, so it is called charged site cleavage. Charged site cleavage. And it occurs at alpha carbon, so that it is called alpha cleavage. And this is called inductive cleavage, since it is occurring at electron donating groups like OH and H, which will be carrying unpaired electrons over it. So it is called as inductive cleavage. Alpha cleavage, inductive cleavage, it is radical site, and this is charged site cleavage. Okay, homolytic cleavage undergoes at positively charged ion. Heterolytic cleavage occurs at radical site cation. And examples for homolytic cleavage are alcohols and amines, where for heterolytic cleavage are ethers. Ethers will be carrying COC, right, means oxygen atom. So between carbon and oxygen, bond breakage occurs. So oxygen will be carrying lone pair of electrons, and these electrons means at this site heterolytic cleavage occurs between carbon and oxygen. Where in alcohols, between alpha carbon, carbon between carbon bond breakage occurs, not at functional group. Here it is occurring at functional group. This will occur between carbon and carbon. It is example for simple cleavages, alcohols and amines. Example for radical site cleavage or heterolytic cleavages, ethers. In hydrogen transfer rearrangement, see here, hydrogen transfer rearrangement occurs in aromatic compounds with alkyl substitution. Where hydrogen transfer rearrangement occurs, aromatic compounds with alkyl substitution. For example, toluene. And toluene becomes only cation, not radical cation. And hydrogen transfer occurs at this methyl group to form cation only, not radical cation. It will not be carrying radical in it. Only cation it becomes, and this aromatic compound will be detected in sorry, it becomes aromatic group will be having 6-membered ring, where this will give tropane ring. Due to hydrogen transfer rearrangement, the methyl substitution will form tropane ring, and tropanium ion will be forming through hydrogen transfer rearrangement, and that ion will be detected. This positive ion represents tropanium ion. So that will be analyzed in mass spectrometry. So what purpose a hydrogen transfer rearrangement is used? Aromatic compounds with aromatic compounds will be having unsaturated system in it, where alkyl substitution with alkyl substitution it will be transferring hydrogen to the aromatic group, and it forms a tropylium ring. That means 7-membered ring, which will be carrying positively charged ion, positive charge, and that ion will be considered as fragment ion to detect by mass spectrometer. And retrodiol solder reaction will be having inside the ring it must have unsaturation. That means aromatic compound with a single unsaturation, if it is there, then it will be going for retrodiol solder reaction to give ethylene ion. Okay, it will form ch2 ch how you will write ch2 ch double bond ch2, no, ch2 double bond ch2, ethylenium ion it will give. Okay, this single unsaturation will become ethylene. So that is the product in retrodiol solder reaction. Just refer textbook for a complete chemical reaction of each fragmentation pattern. And in McLafferty rearrangement, it should have at least 3 carbons, that is alpha, beta, and gamma carbon, as we have already discussed. Alpha, beta, and gamma carbon with a carbonyl functional group, where bond breakage occurs between alpha and beta carbon, and from gamma carbon one hydrogen will be transferred to the functional group in order to get a McLafferty ion. Okay, if the molecule is having more number of alpha, beta, and gamma system, then it will be giving McLafferty ions 1, 2, and so on. Okay, so that is how fragmentation pattern occurs. What are the 4 reactions? Simple cleavage, hydrogen transfer rearrangement, retrodiol solder rearrangement, McLafferty rearrangement. And simple cleavage, homolytic, is otherwise called as alpha cleavage, or charged site cleavage, where heterolytic cleavage is called as inductive cleavage or radical site cleavage. And homolytic occurs in alcohols and amines. Heterolytic occurs in ethers, where hydrogen transfer rearrangement occurs with aromatic groups with alkyl substitution. For that example is toluene. Toluene will donate, means transfer hydrogen within intramolecular hydrogen transfer occurs to form tropylium ion, and that is the fragmented ion for hydrogen transfer rearrangement. And next one is retrodiol solder reaction. The compound which has a single unsaturation inside the ring, it will go for retrodiol solder reaction in order to give ethylene as the product. And in McLafferty rearrangement, already we have discussed enough. Alpha beta carbon breakage occurs, and gamma carbon hydrogen at gamma position hydrogen transfer occurs to the functional group. Thereby McLafferty ion is formed. So these are all the 4 fragmentation patterns. Now let's move on to the fragmentation rules. What are the fragmentation rules for getting different fragments? Patterns are saying about only bond breakage and how the fragmented ions are formed. During this formation of fragmented ions, it follows various rules. Okay, so accordingly we will get the fragmentation, ions, fragmented ions. Whether you are understanding fragmentation pattern, it is an important 5-mark question, frequently asked question in university. Patterns. Okay. Ionization methods and fragmentation patterns are important. So you should be able to explain ionization methods, how ionization occurs in all the methods. After ionization, how the molecule is going for fragmentation. So which covers fragmentation patterns and rules. Now say we have seen the 4 reactions of fragmentation. It is common. 4 reactions are common in all the organic molecules which undergo fragmentation. And now let's see about the rules of fragmentation. So 4 ionization methods we have seen, and 4 fragmentation reactions we have seen in mass spectrometry. So remember the number 4. So it will be carrying mostly all parameters of 4, 4. So you can easily remember. Even principle also 4 steps, right? What are the 4 steps? Ionization, fragmentation, acceleration, and deduction. Likewise, what are ionization methods? 4 methods we have seen. Commonly used methods, many are there. Only you have to know these 4 commonly used methods: electron impact, chemical ionization, electron spray ionization, MALDI, matrix assisted laser desorption ionization. And in fragmentation, 4 reactions: simple cleavage, hydrogen transfer, retrodiol solder, and McLafferty rearrangement. Now let's move on to the fragmentation rules. Here also, if you remember only 4 rules, it is sufficient. First, let's see nitrogen rule. What is nitrogen rule? If the mass to charge ratio for molecular ion is even, mass to charge ratio for molecular ion is even. Molecular ion is said with either P plus or M plus. If it is in even numbers, then the compound will be having even number of nitrogen or no number of nitrogen. Nil nitrogen it will be having. Understood the concept? No, if the molecular ion mass to charge ratio of molecular ion is even numbers, then the compound will be having even number of nitrogen in it, even number of nitrogen, or no nitrogen exists. Either 2 nitrogen atoms it will be having molecule, or it will not be having any nitrogen. And one more point, if the mass to charge ratio is odd in number, then odd number of nitrogen it will be carrying. Definitely it will be having 1 nitrogen in it. If the P plus or M plus ion, molecular ion mass to charge ratio is even, the number of nitrogen will be even or no nitrogen. NO represents no, no nitrogen. Don't consider this as nitrogen and oxygen. It is no nitrogen, even nitrogen or no nitrogen in it. If odd mass to charge ratio for molecular ion is present, then it will be having odd number of nitrogen in it, like 1, 3, 5, like that. This is a nitrogen rule followed for molecular ion during the means ionization process. Ionization and fragmentation process. Then next we'll move on to ring rule. To detect unsaturated centers in the molecule, how many unsaturated centers present in the molecule, that can be analyzed by ring rule. Ring rule can be represented with a symbol or equals to number of rings plus number of double bonds plus twice the number of triple bonds. What ring rule says? Number of rings, how many number of rings present, plus number of double bonds, how many number of double bonds are present in the molecule, and plus twice the number of triple bonds. If triple bond it has, we need to add with twice the number of triple bonds. And even using this ring rule, we can calculate molecular formula also. How means, from the molecular formula you can calculate how many number of rings. For that you need to know how many carbons, how many hydrogens, how many nitrogens, and how many oxygen present in the molecule. Take carbon as W, hydrogen as X, nitrogen as Y, and oxygen as Z. Apply in this formula W plus 1 plus Y minus X divided by 2. So what is W? Carbon, number of carbon, plus 1, plus Y is what? Nitrogen, X is what? Hydrogen, divided by 2 will give you number of rings. Okay, so that is about ring rule. And it is Z is oxygen. Okay, number of oxygen. And next rule is isotopic rule. So what is ring rule? Ring rule is nothing but it is equal to number of rings plus number of double bonds plus twice the number of triple bond. It will say about how many number of unsaturated centers present in the molecule, and it also called means calculated by using the formula R equals to R is rings, number of rings present. That is equal to number of rings can be obtained by W plus 1 plus Y minus X divided by 2 will give you number of unsaturated centers, that is R. Then isotopic rule. Next we'll move on to the third rule, isotopic rule. It depends on halides present in the molecule. Okay, halides x minus and this will be called with halides, and halides will give in mass spectrum m plus 1, m plus 2 and m plus 3 peaks. M represents molecular ion, molecular mass. Molecular ion peak you can consider from the molecular ion peak. If plus 1 mass it contains, then the peak is due to halides. Or if it is having m plus 2, for example, around 100 mass to charge ratio, m plus peak is appearing, you may find it 100 not 1, 100 not 2, 100 not 3, likewise peaks. So that peaks are due to halides. Okay, and this is explained by isotopic rule. When number of means when increasing, then a percentage relative indents also will be increasing only for halides in mass spectrum peaks. Number of isotopes are analyzed, means it will be having high relative indents. Percentage relative indents will be increased. That means when number increasing here represents mass, when it is increased 1, 2 and 3, relative intensity also will be increasing, and this represents and this will occur due to only halides, so that we can analyze isotopes for the particular molecular ion. What are all the different isotopes for molecules are existing through halides analysis. From m plus 1, m plus 2, m plus 3 peaks we can analyze. And that will give percentage relative intensity, relative abundance. Relative abundance will be high. Ra represents relative abundance. In the mass spectrum, y-axis we will be taking percentage relative abundance, and in x-axis we will be taking mass to charge ratio. So mass to charge ratio will show whether m plus ion peak, molecular weight of m plus ion peak, and all these peaks. These peaks are considered as isotopic peaks, and isotopic peaks here is due to halides. When halides are existed or heteroatoms are existed, and this will give additional peaks, m plus 1, m plus 2 and m plus 3 peaks. And according to the number of means molecular, I mean, mass to charge ratio is increasing for this, then relative abundance also will be increasing, and from this we can analyze what kind of isotope is existing. M plus 1 peak mainly is due to carbon isotope, carbon 13 isotope. Okay, and next coming to Stevenson's rule. The fourth rule is Stevenson's rule. If fragmented ion formed from neutral species, it requires less energy ionization potential. So peak with a high intensity will be appearing. Okay, according to Stevenson rule, if fragmented ion formed from neutral species, usually fragmentation occurs from where? Molecular ion. But the fragmentation occurs from directly from neutral species, then it requires only less energy ionization potential, right? We don't need to apply 10 to 15 electron voltage for ionization, since fragmentation occurs from neutral species itself, so it consumes only less energy ionization potential. In that case, you may find intensity of that peak will be high. That means it may give 100% relative abundance for the particular fragmented ion. So the peak which has a highest intensity in mass spectrum is called as base peak. The peak appears at high intensity is called as base peak. So now what are the peaks we have discussed? Molecular ion peak, m plus 1, m plus 2 and m plus 3 peaks. They are due to heteroatoms or halides. Okay, m plus 1, m plus 2, m plus 3 are due to heteroatoms or halides, and this will give information about isotopes. Okay, all additional peaks. Where molecular ion peak will tell about what is the exact molecular weight of the molecule, and then this one, what another peak? Base peak. According to Stevenson rule, if the fragmented ion formed from neutral species, it will be having less energy ionization potential, so that it will appear at high intensity peak. So whichever peak among all other peaks, whichever is having high intensity, then that will be considered as base peak for all other peaks. So base peak will be having relative abundance. Relative abundance is nothing but occurrence, relative occurrence of the particular peak or particular group, fragment or molecule in that particular molecule, how much it is occurring. If it is 100%, the role in that molecule will be high. Even when you are concentrating for any activities, the particular group will be having more active, means more activity, therapeutic activity will be high for the particular isotope. That's why we need to study all this. Okay. So whichever is high intensity isotope present in the molecule, that will be considered the peak due to that particular molecule is called as base peak. So with 100% relative abundance, the intensity will be high, means the peak is considered as base peak, where all other peaks will be having less intensity comparing with this. This is said by Stevenson rule. And next, so three peaks we have seen: molecular ion peak, base peak, M+1, M+2, and M+3 peak. Molecular ion peaks were having high molecular weight, where molecular M+1, M+2, M+3 will tell about isotopes present, and then that will be due to halides and heteroatoms. And next will be 100% intensity, whatever peak is having, and that will be considered as base peak. So three kind of peaks we have seen, and now four rules we have completed: nitrogen rule, ring rule, isotopic rule, and Stevenson rule. Now let's move on to the next rule, even electron rule. Even electron rule for fragmentation. When radical cation, already I said what is radical cation. When it loses one electron, it will be carrying one positive charge and cation. So when radical cation goes for fragmentation, so single electron fragmented ion with radical cation. Single electron fragmented ion. That means, just a second, I will connect to the battery and charge and join. So according to even electron rule, what it says means, when the radical cation is going for fragmentation, it will be giving one radical cation itself as fragment, and another one will be either radical or will be cation. Okay. One ion will be fragmented ion will be either it will be carrying radical species or only it will exist as cation without electron. So this is called even electron rule. Even electron rule. For example, here you can find radical cation. When it goes for fragmentation, one fragment which is formed from this will be called as fragmented ion. This ions, either it will be of radical cation or cation. One of the ion will be carrying both radical and cation, and one of the ion will be carrying only cation. Okay. And one more, if even electrons are present, even electron means only positive ion, it will be giving only positive ion. Okay, if odd electron is present with a molecular ion, it will be going for either the same radical cation fragment and cation. If even electron ion is present, only it will give even electron cation. That means if it is not radical cation, it will give only positively charged ion. This is about even electron rule. Even electron means electrons will be in paired condition. Radical cation, it will be having one electron and one positive charge. When it is going for fragmentation, it will be giving one fragmented ion as radical cation and another one will be as cation. Okay. And next rule is, sixth rule is the rule of 13. Rule of 13. To detect the molecular mass of the compound, that means even you can find molecular formula from molecular mass by using rule of 13. Okay, from the mathematical calculation itself, we can find out molecular formula from the obtained molecular weight. Just consider that M plus ion peak is appearing at 121 gram per mole. Okay, and then you have to know how many carbons and how many hydrogens will be existing for this 121. So carbon and hydrogen mass, you calculate how much, what is the mass of carbon, 12, and mass of hydrogen is 1, so total is 13. Divide the whole molecular weight divided by 13 will give some fraction 9.3. So consider main value as, apply this value in Cn, Hn plus R. N represents number of carbon, number of hydrogen, and plus R is remainder. Where Cn will be 9, say Hn also will be 9, plus remainder will be some heteroatoms existing of heteroatoms, nitrogen, oxygen, due to nitrogen and oxygen. So R is remainder, that is 4, where N is 9. Remainder of this division 121 divided by 30. Okay, so C9 H9 plus R 4. 4 is R is 4, where carbon is 9 and hydrogen also 9. So when you substitute here, you can find for this molecular weight what will be the molecular formula. Okay, whether how many heteroatoms, 4 heteroatoms, either nitrogen and oxygen, N2O2, like that it will be, and H and N you can find C9 and H9. So likewise we can calculate molecular formula from molecular weight. This is molecular weight, and from using this formula you can find molecular formula. And next process is acceleration. So molecular ion and fragmented ions formed through ionization and fragmentation processes according to fragmentation pattern and fragmentation rules. It will be passed through next part of instrument, that is mass analyzers or mass filters will be calling. Analyzers or mass filters, they will be used for acceleration. And different mass analyzers are there for the same purpose, filtering the ions formed according to its mass to charge ratio. One is called a single focusing mass analyzer, double focusing, time of flight, and quadrupole mass analyzer. There are 4 mass analyzers. Okay, single focusing, double focusing, time of flight TOF, and then quadrupole mass analyzers. Mass analyzers are called as mass filters. They will be accelerating ions. Now let's see what is the first one, single focusing. You consider this is ion source where ionization occurs, all positive ionic charged molecules by means of either electron impact ionization or chemical ionization. Through ionization and fragmentation process, ions formed will be focused onto the magnetic field only in order to arrange the ions or accelerate the ions according to mass to charge ratio, where I said that heavy molecules will be having means will be moving slowly, where lighter molecules will be moving fast. So according to its molecular weight, it will be arranged in the field. So magnetic field will be provided in single focusing. In single focusing mass analyzer. In double focusing, that means ions are focused only in single field, that is called a single focusing mass analyzer, that is only in magnetic field. Okay, and if the ions are focused first with magnetic field and then with electric field, okay, electric field, then it is called as a double focusing mass analyzers. Okay, yeah. So will be when we will pass the ions in both the fields, electric and magnetic field, it will be called as double focusing. Since it is focused into 2 fields for acceleration, where in this field, when the field is kept, the ions will be arranged according to mass to charge ratio for the detection. In time of flight, only electric field is applied uh, for acceleration based on time of flight. That means within a given time, all the ions will be accelerated. Okay, and it follows Newton's second law, that is force to ions given will be equal to mass and acceleration. Okay. So when the ions are kept in electric field and magnetic field, ions will take a circular path or radical path before going to detector. So from ion source, it will be taking circular path, or in both electric field and magnetic field. So the movement will be said with half mv square. And next about quadrupole analyzer, where you can find a quadrupole, four poles. So in between that, ions are accelerated to the detector. Four rods will be used with the radio frequency quadrupole. Okay, with the radio frequency, it is having or RF poles will be calling positive and negative poles. Okay, so in between these poles, quadrupoles, ions will be passed where it will be accelerated to the detectors. So these are all the four mass analyzers used in mass spectrometry for the acceleration process. Okay, and which analyzer will be used for tandem mass spectrometry means quadrupole analyzer. Tandem, you should have heard, it is not N, it is M, tandem mass spectrometry, MS. The quadrupole analyzer is used. So according to the analyzer use, mass spectrometry also called with a particular name, either TOF, that is time of flight. It is not light, flight. FLIGHT, time of flight mass analyzer, TOF, and if it is double focusing mass spectrometry, single focusing mass spectrometry, TOF mass spectrometry, and quadrupole. Quadrupole analyzers are used in tandem mass spectrometry, so it is called tandem mass spectrometry. Okay. And ESI and mass multi ionizations are used in protein characterization. Okay, but already I said in yesterday class itself, what is the use of molding matrix assisted laser desorption ionization. If we cannot make directly as the ion, we can make some matrix, and the matrix surface will be made as ion through laser desorption process, so that those ions with macromolecules, proteins are macromolecules, those also can be analyzed. Then coming to the detector part, detectors used in mass spectrometer in order to analyze cations formed. What are all the detectors means? Electron multipliers, Faraday cups detector. Electron multipliers will be converting ions to electrons. Okay, and these electrons are recorded as signal. Where Faraday cups detector or charged particle detectors are used. Okay, here mostly ions will be converted to electrical signal. That is the use of this detectors. And ion to photon detector, ion will be converted to photon, and photon will be recorded as electric signal. Then micro channel plates, this also another form of electron multipliers. Micro channel plates, here electron multipliers are used. Where in other spectrometer, photon multipliers, PMT, we have discussed. Here electron multipliers are used in mass spectrometry. So what are the detectors? Electron multipliers, Faraday cups detector, ion to photon detector, microchannel plates. Here also four detectors. So you can remind the points. Four detectors are used. What are the detectors? Electron multipliers, Faraday cups detector or charged particle detector, then ion to photon detectors, microchannel plates are electron multipliers. Then let's see about mass spectrum. What are the peaks you may get in mass spectrum? Mass to main peak, M plus peak. With block letters, if you give a M, that is molecular ion peak, and all other additional peaks, M plus 1, M plus 2, this all due to isotopes. Okay. M plus 1 peak mainly obtained for C13, carbon 13 isotope, where other peaks, M plus 2 higher peaks and all due to halides and heteroatoms, and peak which is having higher intensity is called as base peak. Okay. This is about mass spectrum, and in x-axis we'll be taking mass to charge ratio. In y-axis it is percentage relative abundance. Relative abundance about relative intensity of each ion, both parent ion and molecular ion. Molecular ion and fragmented ions formed through ionization and fragmentation are detected, and it will each ion mass will be analyzed, and from that molecular formula also analyzed for getting structural information. This mass spectrometry interpretation also you can will be doing in practicals. There you can learn. Okay, and that's all about mass spectrometry. Here it is used for detecting impurities, and we can analyze pK values, and protein characterization, trace gas analysis. It's all used for all the purpose. Mass spectrometry is used for mainly to analyze impurities, protein characterization, and to get molecular formula and molecular mass of unknown compounds, and comparing known compounds with the standards. And important 5 mark questions are ionization methods, fragmentation patterns, and fragmentation rules. Then even you will be asked with mass spectrometric instrumentation. Hmm. So you have to write what is single focusing, double focusing, time of flight, and quadrupole mass spectrometric methods. Okay. So with this mass spectrometry gets over. So we have discussed principle, instrumentation, and applications of mass spectrometry. Only according to your syllabus, you need to know the introduction, how what is mass spectrometry and what are the principles behind it. Here we are not using electromagnetic radiation for analyzing the molecule. We are using high energy electron beams or chemical gases, or electron spray ionization methods, or we are using source for ionization is different, laser disruption or electron spray ionization, electron impact and chemical ionization are used. And for fragmentation, better we can go with the electron impact ionization, where we can get high fragmented species. What are the fragmentation patterns? Homolytic cleavage, heterolytic cleavage, that is simple cleavage methods, hydrogen transfer rearrangement, McLafferty rearrangement, and retro-Diels-Alder reaction. Then what are the fragmentation rules? Nitrogen rule, ring rule, isotopic rule, Stevenson's rule, even electron rule, and rule of 13. 13 represents the mass of carbon and hydrogen. Okay, 12 plus 1, 13. So if you divide your molecular weight by 13, you will get some fractions that is substituted in CnHn plus R in order to calculate the molecular formula. Okay. And this is theoretically we can calculate by using rule of 13. Through practical analysis from the spectrum, you can analyze what is the molecular formula for each fragment and molecular ion peak. Then the spectrum appears in the x-axis mass to charge ratio, and in y-axis percentage relative abundance we will be taking for mass analysis, and mass spectrum is otherwise known as line spectrum. Okay. And for ionization chamber is required in instrumentation, and for ionization and fragmentation both occurs in ionization chamber. Once the ions are formed, they are accelerated. For acceleration purpose, we are using analyzers. What are the four analyzers? Single focusing, double focusing, and then what? Third one is what? Time of flight and quadrupole mass analyzers are used. So according to the analyzer used, the mass spectrometer also called with that particular name. Single focusing MS, double focusing MS, time of flight MS, likewise. Okay. And quadrupole MS. Quadrupole MS will be used in tandem mass spectrometer, so it will be called as tandem MS. And then what is next? Detectors. What are the detectors? In order to detect ions, ion to photon electron detectors, electron multipliers, charged particle detectors. Okay, so these are all the detectors used in mass spectrometry. Four detectors used in mass spectrometry. Faraday cups detector, electron multipliers, charged particle detector, ion to photon, microchannel plates. Okay. With this, I am completing mass spectrometry. In the next class, we'll discuss about ESR. Let me know now who are going to take a seminar on thermal methods and polarimetry. Thermal methods and polarimetry. Now I'd like to know your names, and you have to take your give seminar in the next week. Okay, Monday one seminar, and same on Wednesday in the same hour. You have to one of you have to give seminar on polarimetry. So Monday thermal methods seminar, Wednesday polarimetry seminar. With that, I will be completing your spectrometric analysis. Only ESRS left. Then I will take what is electron spin resonance spectroscopy in the next class. Once your seminars completes, I will cover electron spin resonance. Then we will move on to electrochemical methods. Okay, electrochemical methods hardly it will take one or two classes. Then quality assurance, and that will be taking nearly two classes. So within 75 hours I will be completing your syllabus. Okay, then if we get any extra hours I will conduct however offline classes. Okay, good. Then come here, we'll have seminar directly. Get prepared and come. So Subadarshini, are you ready for thermal methods? In thermal methods, DTA and DSC, two techniques will be there. So two of you can share the technique. Already Akashna has given seminar, so I'm not going to give her. So any one of other 18 members can select. Jackson, you take polarimetry. Okay, Jackson, you have to get
Ma'am.
prepared. Polarimetry, you have to get prepared. If any doubts, you can contact me. Okay. So on
Okay, ma'am.
Wednesday, you have 8 days. On Wednesday next week, you will be having seminar. On Monday, Monday 11 to 12 hour, who will be taking? Monisha. Monisha and Subhadarshini, you both can share the thermal methods. DTA, one of you take differential thermal analysis and one of you take differential scanning calorimetry. Okay, the concepts are simple only. That's why I'm assigning seminar to you. So get prepared on this and give seminar in the next week. Thank you, Pa.
Thank you,
Kindly
ma'am.
cooperate for
Thank you,
syllabus
ma'am.
completion. Since your syllabus is too much, we need to cover within a prescribed time. That's why. Okay. And you may get exams for your second form D, second year's exam. So meanwhile, we'll complete the syllabus of third year. Thank you, Pa.
Thank you,
Comes.
ma'am.
Hope you all have got vaccinated, right?